Good evening. The last time we looked at how to determine the ground state term for a D3 atomic orbital. Today, I want us to look at how to determine the ground state term for a D2 atomic orbital. So, first of all, you need to write down the angular orbital quantum number for a D orbital. We know that is represented by L, and for a D orbital, it is 2. Then we have to know the magnetic quantum number. It is represented by the ML. The magnetic quantum number starts from plus L, 0, and negative L. So in this case, since we have the L to be 2, we have plus 2, we begin from plus 2, plus 1, 0, negative 1, and negative 2. Then we write down the spin quantum number represented by ms. So each electron can spin upwards, or represented by plus half, or spin downwards, represented by negative half. So it's either it spins against the field or spins in direction to the field, which is represented by either plus half or negative half. Then after that, we need to draw the orbital, the d orbital. We know the d orbital is a degenerate orbital. So we have 1, 2, 3, 4, 5. We have 5 orbitals. And you write down the magnetic quantum number of each orbital. So we have here plus 2, plus 1. This represents 0, negative 1, negative 2. Since we have 2 electrons, because we want to determine the ground state term for D2, 2 means 2 electrons. So we refer with 2 electrons by obeying the rules in filling electrons. So in this case, we obey Hans' rule, because according to Hans' rule, if we have degenerate orbitals, we refer them with single electrons in the same spin. So since we have only 2 electrons, we only fill with 2 electrons. After filling with the electrons, then we need to calculate the total orbital angular quantum number. To determine the total angular quantum number, we need to add the orbitals containing the electrons. We need to add the magnetic quantum number of the orbitals containing the electrons together. So let me use a different color here. So the total orbital magnetic quantum number represented by ML. So since we have an electron in this orbital, the magnetic quantum number is 2, and an electron in this orbital, magnetic quantum number is 1. So we have the total orbital magnetic quantum number to be 3. Then we determine the total spin quantum number. This electron can spin either plus half or negative half. But remember that in this direction, it is only spinning plus half. Plus this orbital is also spinning upwards, so also plus half. So we get a total of 1. Now, if we have the total orbital angular quantum number to be 3, then if you have it to be 0, then the term is an S. If it is 1, then it is P. If it is 2, then it is D. If it is 3, then it is F. So since we have it to be 3, we have the F term. But we also need to determine the spin multiplicity by using the formula 2s plus 1, where the s represents the total spin quantum number. So we have 2, we replace the s by 1, then plus 1. So 2 times 1, 2, plus 1, 3. So we write the spin multiplicity here. So the ground state term for a D2 atomic orbital is 3f. Thank you.